Welcome to the video solutions of CodeDrift.
So let us move to the next problem, which is, can you find the GCD? Okay, so the problem says that you are given a long number a in the form of a string, right? And we have to we are also given an integer b. Your task is to find the GCD between a and b. Can you solve it? So basically we will be given a very long number a, okay, and since it will be very long, we cannot store it in any data type, so we will be storing it in the form of a string. And we will also be given an integer b, and we have to find the GCD of a and 10 to the power b. The problem constraints are like the length of the string a will not exceed 10 to the power 5, and it will also be not empty, so it will have a minimum size of 1. The b, that is your value of b, will be lying between 1 to 9, right? Then let's consider some example. Okay, so let's say a is given as like 1 2 3 4 5 and b is given as 2. So we will have to find the GCD of this number, which is 1 2 3 4 5 and 10 to the power 2, which is 100. So basically we have to find the GCD of this number and 100. So what will be their GCD? Okay, so what is GCD? By the way, GCD is the largest number which divides both the numbers. So when you say GCD of a comma b is equal to x, what does this mean is that x is the largest such number which divides a as well as b. Okay, for example, if you consider the given case, you will find their GCD will be equal to 5. Okay, so you see that 5 divides 100. Okay, 5 into 20 will give you 100, so 100 is divisible by 5. Similarly, if you consider this number will also be divisible by 5, since its unit digit consists of a 5. Okay, let us consider another example. So let's say if your a is given as 7 and b is given as 1, then your you have to basically find GCD of 7 and 10 to the power 1. So that will be GCD of 7 and 10. Okay, so as you can see, the highest number which divides both 7 and 10 will be equal to 1 in this case. Okay, and yeah, here it should be lying between b may be equal to 1 as well. Okay, so let us look at now an optimal approach. So in an optimal approach, what we can do, we know that whenever we want to find GCD of a comma b, basically we use Euclidean algorithm. Okay, so what Euclidean algorithm says is basically GCD of a comma b will be same as GCD of b comma a modulo b. Okay, so this is what is known as GCD Euclidean algorithm. So basically we will use the same thing over here, right? For example, if we want to find GCD of, let's say that string is basically represented as s and 10 to the power b. Okay, so what we will do, we will simply write it like this: GCD of 10 to the power b comma s modulo 10 to the power b. Okay, so you might think of, okay, I can find this. How will I find this? Since s is very huge, we cannot store it in any number. So how do we calculate s modulo 10 to the power b? Okay, so let us consider some examples to have a better understanding that how we can find this actually. For example, if s is given as 3 7 8 9 and b is given as, let's say, 2, so it means you have to find 3 7 8 9 modulo 100. Okay, so that will be nothing but 89, right? Similarly, if you consider some number like say 36 and b is given like 1, so you basically need to find 36 modulo 10, so that would be nothing but 6, right? So if you just try it out with various values of s and b, you will find that whenever you need to find s modulo 10 to the power b, it is nothing but the number formed by the last b digits of s. Okay, the number formed by last b digits of s. For example, when you have to find this one, you basically see that there are two zeros, which means it is actually 10 to the power 2. So when you are taking modulo s with 10 to the power 2, you are basically taking the last two digits, that will give you 89. Similarly, when you have to find 36 modulo 10, which is 10 to the power 1, you are taking the last one digit of s, that is 6. So it means we can easily find this thing, okay, by simply taking the last b digits of s. Okay, and if you are taking the last b digits of s, that will surely be always be lesser than 10 to the power b. okay, the number found by taking the last b digits of s will always lesser than 10 to the power b, because it's the property of modulo, or like whenever you find a modulo b, it's always gonna lesser than b. Okay, since we are taking modulo with 10 to the power b, whatever is this complete value, that will always be lesser than 10 to the power b. So it means although we cannot store s into some number, but we can store the exact value of the number found by last b digits of s. And once you are done with that, you can simply use the, either you can use standard Euclidean algorithm, or you can use the inbuilt GCD function, maybe present in your language. Okay, so either way, the time complexity would then be reduced to log of 10 to the power b. So this is the time complexity of finding the GCD after you find the number found by last b digits of s. Okay, so this is the time complexity of finding the GCD after that, but before that you have to also get the last b digits of that number. So for doing that, you will just do a order of b linear traversal. So your time complexity will be actually this. Okay, now coming to the total space complexity, it will be nothing but order of n, where n is the size of the string that you will be taking input. Okay, so whatever is the number of digits in that thing. Okay, the extra space complexity will be order of 1, because we will not be using any extra space, right? We are simply just using some local, we will be using some local variables for storing this GCD and the numerical value of this last b digits of s. So that's why the extra space complexity will be order of 1. So let us now look at the pseudocode for it. So here we have defined a function find GCD. It will accept a string a, b, and the size of the string. Okay. First of all, we will be storing the last b digits of the given string a. So for storing it, we will use num. So num will be initially 0. Then we just iterate over the last b digits. So the leftmost digit that we need to take into account will be n minus b. But if it goes beyond 0, or like goes beyond 0, that is becomes negative, then in that case we will take 0. So for I is equal to maximum of 0 comma n minus b, I is lesser than n, I plus plus, num will first of all get multiplied by 10, then number plus is equal to integer value of a of I. For example, if you are given a string like 4 2 3 7 and let's say b is given as 3, so it means you want the last 3 digits. So initially number would be 0. Then what you will do, you will say I is equal to maximum 0 comma n minus b. So n is here 4, 4 minus 3 is 1. So you will iterate from this point till the last index 3. Okay, and you will first of all multiply your number by 10, then you will add the integer value of this character. Okay, so ultimately after doing this for loop, after getting over from this for loop, you will be having the numerical value of the last b digits of the string a. Then you will find the value of 10 to the power b. So num1 will storing this. So num1 will initially be 1, and then you iterate for I is equal to 1 to b and multiply num1 by 10 at each step. Ultimately you will be getting num1, and then you will return the GCD of num and num1. So let us now look at the dry run operator. So let us consider the very first example. So in that, string a was 1 2 3 4 5 and b was 2. So what we will do, we will initialize num with 0. Then for I is equal to maximum of 0 comma n minus b. So here what is the value of n minus b? This basically n is here 5. 5 minus 2 is 3. Maximum of 0 comma 3 is 3. So it means that we will start iterating for I is equal to 3, and we will go till I is equal to 4. Okay. So when I is equal to 3, num is multiplied by 10, so num remains 0, and num plus is equal to integer value of a of I. So I is 3. So what is the value of the third element of this a? So if your index is 0 1 2 3, so this is 4. So it means num will get updated to 4. Okay, you added 4 to num. Okay, then your iteration will go for I is equal to 4. So when I is equal to, so this iteration was completed after I is equal to 3, we are having the value of num as 4. When I is equal to 4, then num will get multiplied by 10. So the value of num becomes 40. After that you add the value of a of integer value of a of 4. So a of 4 is 5. Okay, in character you add it add its integer value, that is 5, to num. So this becomes now 45. Okay, so number finally contains 45. Then after that I becomes 5. So you will just stop this for loop. Okay, you will just break out of this loop. Okay, so num is 45, right? Then you move to here, num1 is 1. You iterate for I is equal to 1 to b. So b is here 2. So when I is equal to 1, you multiplied num1 with 10. So num1 gets to 10. 1 into 10 is 10. For I is equal to 2, when I is equal to 2, num1 again get multiplied by 10. So num1 finally contains 100. Okay, now you will be returning the GCD of num and num1. So num is 45, num1 is 100. So the GCD of 45 and 100 is nothing but 5. So ultimately you will be getting 5.
So thank you for watching, and please like, share and subscribe our channel.